Hey guys, we got a little bit of wiring to do today. Customers modifying their pump system, and they currently are sucking water out of a small trough. They have a float switch in there, but the float switch is in series with the direct run logic here, hardwired into the coil logic of this contactor. And so in the event that the water in the trough gets low and that float switch opens, they have to send an operator way out here to manually hit this low-level reset push button here. What they'd like though is if we could tie it into their fancy SCADA so that they can see the status of the float switch and reset the pump and run it remotely. So we're going to kind of dig through the existing wiring here as best we can. Hopefully it's just a simple change, and try to make it so the SCADA sees the position of the float and decides to start and stop the pump on its own based on that float switch input. All right, let's start digging into the wiring. Okay, first step is to shut this thing down and then start figuring out the wiring here, the exact series logic that float switch is in. So we'll go ahead and shut it off. Okay. Let's just see where our voltage is. Where is that coming from? I think it's coming from over here, honestly. So now it's a 120 relay output over there on our PLC, and it's a question of where that's the beginning of our run. There is going to be 120, and it's going to go essentially through PLC relay output. And the source for that 120, I believe, is inside of here. We've got this blue and this blue. Let's shut off our pump power as well. So we're getting all friendly in there. So now we shouldn't have any 480 in here. Let's check that. Good. Good. Ground. Good. Okay, but there is, I suspect, still some 120 in here, and I want to just identify where it is before I turn it off. So here's our return back from our controls, and here is our source out. It's going on to that little relay in the back there, and yeah, he's lit up. Okay. What were they doing here, I wonder? Let's see if we can get in there without making any sparks. Okay. So if I pull him out, so we've got that 128 is on 3. 3 is the normally open of number 1. So that's probably hot all the time, number 1. And this coil is fired from 2 and 7. And this is 120. There's 7. And there's 2 are neutral. So yeah, the way this is our run feedback interposing relay, and this is our low, or this is their low water reset relay. So when the float opens, it opens this relay until you close it momentarily by pushing this momentary push button. Then that holds it closed until the float opens again. So I don't really need any of that logic anymore. This is all temporary until they get, and this is why it's so disheveled, this is all a temporary setup until they get their permanent pump installed with a new VFD starter and all this gets demolished. So for today, simplicity is going to be the key. This cable is the other end of their float switch. It is going on to 8 and it's getting a constant hot. Yeah, and then from 8 it's either going to 6 or 5 or both. There's 6. So from there it's going down and it's going to 7. So that's our coil, so that's what holds it true when it's true. And then the push button just shunts that out. Push button is also on 8. And so the float has to be true. The float has to be closed for the push button to work. Okay, perfect. Nothing there. Something there though. So we do have 120 in there. Let's just shut down the 120 controls for the site. Nothing's running. That should do it. Let's see. Very good. Okay, so no power in there. So now what I want to do is get the float off of here because I want to maintain that run feedback interposing relay. That's fine. And I want to get the float off of here. That's fine. And then I also want to remove the logic for this relay. The only things I want in series with the coil of this contactor is the discharge temperature switch, the motor overload, and the SCADA system. All those dry contacts I want in series with the 120 coil on this thing. So currently, we just need to take this wire and put it onto a wire that is always hot, which is this guy right here. And then we'll always have 120 on the other end at the beginning of our rung. I can just back him off. Basically, I'm taking the float. There we go. I'm taking the float completely out of the hardwired series wiring of this motor contactor's coil. And I'm just going to take the float, which is this pair, and I'm going to bring it into my SCADA system. Now, the million-dollar question is, do I already have a pair of wires in here leading back to my SCADA that are spare, or do I need to pull new? So let's investigate that. If I'm lucky, I'll have some spares in this gutter. Otherwise, I will be pulling some in those conduits up there. All right, let's check in and see what's up. So looking in this gutter, there's quite a few wires, but there aren't any spares running back to our controls. So what I'll do is pull a pair of 18s, number 18, from our starter back to the SCADA can and get them landed on a digital input. That way we can start testing. and get it in each end and land it and test it out. Well, now that I've got the pairs in here, and just looking at my PLC and my input blocks, I'm not seeing any spare digital inputs that I can land this on for the float switch. So I'm going to take a look at the wiring diagram, see what they are, and we may have to sacrifice one that's not as used temporarily in order to gain this feature. So let's see here, there's relay outputs, here's the digital inputs. We do have some inputs from our power supply here saying battery low or on battery. We could probably live without battery low for the time being. The rest of these I could say is pretty critical. Yeah, I think we're going to do that. So what we'll do is we'll temporarily change. I think we need another module here, unfortunately. I don't know that we have, though. We're kind of using them all. But we'll figure that out later. So for now, let's change X1. And that is, yeah, X1 was battery low, temp, we'll call it a transfer float switch, transfer float switch. Okay. Alright, so the first thing before I landed here, I'm just curious if this float switch is normally open or normally closed. I'm going to assume it's normally open. Normally open and closes when it rises. So let's see here though. Just a continuity check. I've already got it landed on the other end. Helps if the meter is on. There we go. So yeah, closed, so it would be normally open. Close on levels change or state change. All right, and then we got all our notes for that. I can put that away. So that is going to be X1 right there, 221. 221, yep, good. And then I believe that's the other thing to check. Write that down. So we'll write down that our transfer float switch is normally open. And then I believe all these digital inputs are switching to negative. Yeah, switching to negative. Perfect. So we can put this guy on a DC negative bus over yonder. He's getting pretty crowded. Let's see if we can squeeze him in on this one. Okay, and then when we land him on X1, we should see X1 right there light up. Let's see. Perfect. Great. And this is one of those classic places where, oh, it's temporary. Everything's temporary. Oh, this is temporary. Oh, that's temporary. One of those classic places. So just get it in. We don't want it permanent. We're going to rip it out later. We're going to upgrade it later. We're going to upgrade it later. It will get upgraded. It's just frustrating when the temporary stuff piles up over years. But so far we've kept our stuff pretty clean as we're slowly upgrading them from where they were when we took on this customer. So things are much better. I think we are ready to call our integrator, my guy Josh, and have him look at the program. Or one option is I connect to it with my laptop here myself. But let's give him a call and see what he's got in mind. Cool. Yeah, I've got it all ready to test. Thanks. Okay, bye. Hey, bro.
I booked in. What input are we going to use?
Okay, so I noticed right away when I went to wire it that we don't have any spare digital inputs.
Great.
So I went ahead and got rid of low battery from the battery supply, battery charger. Yeah. So X1 is our float, and it is normally open, so it opens on a fault.
Okay, but sorry, which X was that? I missed the number.
X1.
Okay. Okay, and it opens on fault, you said?
Yeah, opens on fault.
Load. High. Okay, there we go. So right now I'm seeing it as energized, which means that the float is not active, aka run the pump, right?
Yeah, the float is up, so we're good. Pump can run.
Yeah, run pump. So energize when we want to run the pump.
Yeah.
Okay. 0, stop pump. Okay. Let me.
And everything is lined up right now. It could be started. I don't have an HOA for that pump here, a handoff auto, so it's all done through the SCADA.
Okay. Well, let me just quickly look at what our control logic is. So give me a second there. Control, oh, I see. Weird start. Okay, and currently, when there's a weird call for water and our cycle stop is good, and there's no failed start, and let's see, and now I'm just going to add our float in, so when our float is active, we can run it.
And I believe they wanted that float fault to be like a lockout that they have to reset. You know, not automatic reset.
Okay. Oh, good. Excellent.
I believe.
Yeah, I mean, that's how they currently have it. Right?
Yeah. Totally.
Okay. Well, I guess I should confirm that because I'm about to write it. And it'd be nice to test it, right?
Yeah, that's what I'm thinking.
And just confirm.
All right, give me a call. Give me a call back when you're ready to test.
I will. Okay,
Thanks.
sounds good.
Okay, bye. All right, what do you got?
He wants it to interlock. So he just wants,
Automatic reset.
yeah.
Okay.
So I'm writing that changeover right now. And then we are going to be off and running. I'm going to have to change my SCADA to show. Otherwise, we're going to be like triggering battery alarms, just thinking all out the blue. But that's easy. Writing over the change now.
Okay.
It's taking a while.
I can tell.
Okay. It's written over. The failed starts active. That's the reason the pump won't run right now. I'll just reset it.
Go ahead.
I think you could with the on-site full reset too, but
Yep. That works.
yep, done. All right, pump is up and running. I guess trigger the float and see if it stops. Huh?
Helps if the breaker's closed. Okay, I'm gonna open the float signal.
Yep.
There it goes.
Great. Boom. I'll
Yep.
just edit the SCADA.
And
make
that's
it
good
look
you
nice.
got it straight from him that he doesn't want it locked out. So if they get any weird stuff with their float, we said we wanted to do lockout, but he wanted to do it automatic. So
Yes, I'm going to summarize it in an email right now.
perfect. Yep. Okay. Thanks, Josh.
Done. All right. Sweet.
Okay, bye.
Thanks. Bye.
All right, we got it all working, got it all tested. Temporary wired, temporary permanent, the way these guys like. Pump's running, float switch protects it. See you on the next one.